Hi, everyone. My name is Zach Williams. I work for the ONF. This talk is on logging and monitoring in Cord. It includes a lot of the learning and changes that we've made in Cord since working post 6.0 on the SIBA project. So what are the goals of a logging and monitoring system? Fundamentally, they're what is the system doing? You can have a system running, but if you don't know what it's doing and you don't know if it's operating properly or improperly, it's not of much use to you. So what are we trying to do? We collect statistics, other items or errors, monitoring data. We get logs so we can tell a historical view of the system, aid in diagnostics and troubleshooting. And also, one of the other goals we had of this system was to lower the barrier of entry, because we have a lot of partners that want to add either value-add services or maybe proprietary components or things like big data integration. And we wanted to be able to expose that data, the things that happen in a Cord pod, to allow new and interesting ways to use that data. So when we came into the SIBA work, which is part of Cord, we really wanted to have a robust FCAP system. And what is FCAP's fault management, configuration, accounting, performance, and security. And if you look at logging and monitoring, they cover most of these. So logging is a fault management thing. You want to find what happened wrong. Again, security is also a logging thing. You want to know after the fact who was able to get in, somebody was allowed in or not allowed into the system. Monitoring then covers things like the accounting, number of, a new subscriber comes on, counting the number of pieces of equipment you have in your system, and performance, packet counting, and that sort of thing. So this is the big picture of what we worked on in the post 6.0. We have various internal services over here. So XOS Core, Volta, and ONOS. We have them all publishing on Kafka topics. And Kafka is our centralized message bus system that we're using to propagate messages through the system. And those get read out by Logstash or the Kafka topic exporter, and then into one of the Elasticsearch, which handles log messages, and Prometheus, which is handling monitoring data. And then those are displayed in a GUI with Kibana or Grafana. So why did we pick Kafka? Well, first, it was being used in Volta and also in XOS. It performs and scales well, and it has lots of API bindings. And we're using it for two purposes. One is to pass actionable messages between components. There are times when an event comes in, we publish something on a message bus on a topic, and then there's a reactive element that happens. So I'm going to give an example just now. And the other thing was to collect and propagate messages, which is how we're using it for logging and monitoring. So to speak to that first point, which isn't really logging and monitoring, but also discusses our use of Kafka, we have events that happen in ONOS, XOS, ONOS, and Volta. For example, a new ONU device comes on, and that happens in Volta. It sends a message to ONOS. ONOS creates an event on the ONU events topic. So a new ONU came on board, and then XOS can react to that and create new models and help create a service chain. Also, this is also used for repairing the system. So if you take down ONOS and you bring it back up, it comes up with no apps in it. So one of the things we did is we implemented Kubernetes synchronizer, which, among other things, can tell if a pod starts and stops. So if what we did in XOS, if the ONOS synchronizer listens for Kubernetes messages, if it sees ONOS having stopped and started, it loads all the new apps and all the config back into ONOS so that you can handle the restart of the ONOS component and automatically configure it. So I'm going to also talk a little bit about Kafka just to set some ground rules. Kafka has topics, so they're a namespace that you can publish events on. They have keys, which are summarizable per topic things. We're not extensively using those, but those could be used for things like If you publish with a key of a serial number of an ONU, you could get the last message that happened to it. There are producers and consumers. Those are things that either publish on or consume from the message bus. And there's an offset, which is the last record that was pulled out of Kafka. That can be used in a system to increase scale. So you could have a topic that you could have multiple consumers reading from a topic, and they could each do work on that and not read the same message twice. So I'm going to switch to talking about logging. So logging answers the 5 Ws. The component that created the who, the component that created the log message. You need to know where this or what this message is and who it came from. What content of the message, usually just a text string. Where in the code base it is. This is sort of if you see a message, you want to know what part of the code base. Was this in Volta, for example, the driver for the piece for a specific piece of hardware? Is this part of the core? It's helpful to know where the failure, or where the error log message came from. When a time, so that it can be set in a temporal context, and the why. So the why is sort of a person would determine that by looking at the messaging context. So this is a simplification of the earlier slide on the logging pipeline. So what we have is we have a log handler. In many cases, in Exos and Volta, they share a Kafka log handler, which is a piece of Python code that we can take log messages and publish them on a Kafka topic. For ONOS, we're using FileBeat. It writes to a JSON file that is okay. In Volta 2.0 or in ONOS 2.0, there's going to actually be a real JSON appender and possibly a Kafka log output that would let us do this more smoothly. Currently, the ONOS logs are not the greatest in the world, but that's improving. Those all published to topics in Kafka. Logstash reads them out. They go into Elasticsearch and then Kibana. Pretty straightforward. So once this happens, what do you get? Here's an example of an ONU being activated. If you can see, I realize the font's really small, but we're seeing messages here from Volta, ONOS, and XOS, all about a specific ONU on a port. So you can see the serial number is the same. If that field was bigger, you'd also see the serial number there. So this lets you correlate messages about the state of the system across different components, which has been really important for both debugging and for being able to know the status of a specific piece of hardware in the system. So structured logging. One of the things that helps with that, especially if you see that there's fields over here, logging but with more data. So key value pairs are passed. A framework automatically adds a bunch of the information. It adds the who, the where, and the when. So it adds a timestamp. It adds where in the code it was. Instance names. So if you have multiple instances of a thing, like a driver or an ONOS, if you had multiple ONOSs running, you'd know which one it came from. And this basically helps with the log correlation. So to give an example, this is out of the XOS code. There's a logging command, a debug that's updating this model, doing a model policy, updating a subscriber. It has all these fields. These fields, when they get logged, they get turned into this JSON blob that gets put in Kafka. It gains some other things like timestamp. It gets which module it's in, the name of the file, the path to what threw or sent that message. And then that JSON gets run, pulled through Logstash, pulled into Elasticsearch, and eventually ends up in Kibana, where you get the date, you get the topic, and all the fields that were in that original call. So that's how you can track back through the system. And other than one of the advantages of this is you can put whatever fields you want in there, and they'll show up in Elasticsearch. But that's also a problem because our state of all the different names of of extra fields sort of has grown. We have a couple hundred fields now, and they're not all correlated, but I'm going to talk about that a little bit later. So just some things to think about if you're writing log messages. You have to think like you're the reader, not the writer. It might be totally obvious to you when you're writing some code what you have it in your mind, but somebody who's coming to this and trying to read this message, they'd be like, what is intended by this? Even if they learn the context, they don't know the structure of your program. So more verbose is somewhat better than less verbose, in my opinion. Also, don't repeat yourself. If you have the same log message in multiple places in your code, people who are trying to figure out where this came from, especially if they're not using structured logging, can get lost. The other thing, don't try to avoid capturing security information. Don't put passwords and human readable stuff in it. Things that can be unavailable by a person. Logging levels. So one of the other problems that we've had, especially with Volta, was it was putting out a huge number of logs, hundreds of messages a second. In some cases, it just would be totally overwhelming. So one of the things we did is worked on making the logging less overwhelming. We tried to reduce the log level, or the number of logs, we tried to change the log levels. Right now, if you log with info on, it's almost manageable in Volta. With debug on, it's still a huge number, but we didn't really want to remove logging commands that somebody might find useful, especially if they're a programmer trying to debug something. Some things to know. Only use error and fatal if you need user intervention. If you're throwing an exception, that shows up as an error. Catch it and throw a warning if it's something that's recurring, like I'm trying to reconnect to etcd or something, or I'm trying to connect to a database. Catch that, print a warning saying that you can't do it, but don't let the exception fall, because then it'll show up as an error, and usually that doesn't mean the same thing. Errors, yeah. So errors are sort of call a person for help when just retries or not. So most of the time, people are going to be, especially in production, they're only going to be at info level. It's not going to be overwhelming. Try and get everything across at info level, especially all the changes. Maybe not enter and exit of functions and that sort of thing. So that was the logging section. The monitoring pipeline. This is very similar. There's Kafka Topic Exporter, which replaces Logstash, and Prometheus, which replaces Elasticsearch, and Grafana, which replaces Kibana. Otherwise, the publishers, the components are the same. It's just they publish to a different topic. Pretty similar. The monitoring format, they're not log messages. They're usually designed to be in a format that is designed with Prometheus in mind. So for example, these are things out of the ONU events, or ONUS KPIs, packet, send, and receive. And these end up, excuse me, these end up getting visualized in Grafana. So you can see increasing amounts of traffic and various things given per the OpenFlow ID of the different ports. So extending this. A lot of people I've heard from a lot of either vendors or service integrators or other people today about about solutions that they've come up with when Cord and Seba didn't have this functionality. So just some guidelines that might be helpful to direct those people. I still think that those are totally great things to do. Add more logging and monitoring functionality to Cord, but the way that we're thinking about doing it, here's some guidelines that might help you do that in a faster way and in a way that integrates better. So if you have issues with latency or round trip time, and you probably would want to make a microservice that interacts with the Kafka bus inside the pod, that consumes things, takes actions. So maybe an XOS service or another microservice that does that. If you need data that's outside the pod, you should probably consume from Kafka, either in the pod or connect to Kafka remotely. format it and forward it to whatever other service that you'd like to send it to. This is currently being done. There's a VES agent that one of the people at the AT&T Foundry wrote that's specific to AT&T and ONAP that takes data off of our Kafka bus, formats it, and sends it upstream to ONAP. If you need different information than is available, figure out a way to either publish it out of an existing component or contribute a new publisher to Kafka. It's pretty simple to do. The APIs are really obvious. It's publish message, feed it some JSON, and away you go. Future work. So as I said, we have a couple hundred fields. We really need to normalize them down. That's a human effort. We have to go through the code and make sure that everybody is using the same field name for the serial number of a specific kind of equipment. A few other things. We could name our topics better. We're thinking we might want a namespace by component name, either like Volta or ONF at the beginning. And then additional data. We're always looking at new, and we really are interested in feedback from the community about the data that you want to be put on the bus so that it can be used. So, alrighty, any questions?
Yes, I have two questions. One related to performance of Kafka.
Okay.
And the other one is, can you filter some messages out of Kafka? For example, say only give me priority one or give me some ACL type concepts from the Kafka?
So Kafka natively has been performing very well. I would push. One of my test things was pushing log messages because we had a performance issue, and I was able to push, I think, several thousand per second into it of log messages from a Python script. It's not. Kafka is very scalable. It's unlikely that you'll hit a Kafka scaling issue. It's being used in a bunch of web scale stuff that's way larger than would be.
Do we have any measurements, like in terms of how long does it take from the time you
you're asking for
transient delay,
latency. We haven't measured that. That would be something good to measure. If anything, it is far below human recognizable latency.
It's more about controlling the radio. So if you want to get the events,
you're thinking of some like a tight
feedback loop with the radio.
That's probably a case by case thing. If that'd be it'd be interesting if you discovered that this is something that would or wouldn't work. That would be interesting to share with the group. And then your second question was?
Filtering. Can you do filtering when you read or when you actually, yes.
Kafka doesn't have a native filtering other than if you wanted to subdivide things by topic. So you can listen on a topic and then filter afterwards. You can also listen on a topic and a key. Or it's very easy to filter based on keys. So having an external component that is a consumer of a Kafka bus and then a Kafka topic and then just gets the data you want would be probably a pretty good microservice to make. Yep.
Just a quick one. Under pod, you're referring to the core pod, not Kubernetes pod.
This is all measuring things that are specifically already running. They're VNFs that we run in the cord pod. So XOS, ONOS, or Volta. There are some other components, BBSim, some of our other simulation things also have been instrumented to publish logs on the Kafka bus.
Do we store these logs in any file?
I didn't talk a whole lot about persistent storage, and I realized that was in my abstract for the thing. So one of I should have made a slide for this. Currently, Kafka is configurable of how long it retains data. We currently are not putting the Kafka bus data on a persistent store, even though that's possible. Currently, it's holding 4 hours of data. we're expecting that people would write, if they wanted to, for example, send data upstream or process it, they would store it in an external solution. So logging data gets put into Elasticsearch. Elasticsearch we have persistence set up for that if needed. If somebody wanted to get data off the pod, we're assuming that a pod sits on the edge of a network, does not have a SAN, very, very high availability storage behind it, that the goal is to get all that data off and into some other system fairly quickly. Those are all tweakable. You can change the persistence, and if there's persistence needed on any of these components, it's fairly easy to configure that in Kubernetes.
So if I want to see the last log I received before my container died, how do I do that?
Could you repeat the question? I didn't quite catch that.
If I want to see the last log before my container died, how do I see that?
So there's not really a correlation of, well, I guess there's certain things that will tell you when a container is up and it goes up and down. We're not grabbing container logs because that wouldn't get us the structured logging functionality. We're logging within the, we're logging using frameworks that run inside the logging framework of the individual VNFs. But you could probably just look for this container, the last log message that I found on a topic, which would be probably the type of the service that you were talking about.
Yeah, and this is just for future work or something like that. Is there any log format you have? Because in my previous jobs, I have seen some of the carriers prefer log format in certain like IPFix or Splunk, or there are 6-7 ArcSight, 6-7 types of log formats. So do we support that?
So right now, everything is coming as a JSON object in the Kafka bus, on a Kafka topic. If there's a need for a different format, probably the best way to do it would be to listen to Kafka or consume from Kafka, perform whatever transform you need, and send it on or to that other system. Okay?
Yeah, thanks.
Are there anything else?
Any other question? So maybe I can ask you one.
Okay.
Is ONF planning to release like a schema for logging, so to make easier for current and future developer to make the story of a single subscriber traceable from when the device came out to whatever happened in his life?
I'm interested in that. We haven't really talked about it, but it makes sense to have a like a schema, or if you're going to report this kind of data, report it with this kind of field with this type.
So just a slight comment on that, or suggestion. So what we've done on the EPC end, adopted VES. So it is somewhat prescriptive.
Okay.
Can do that, so maybe you just follow that.
That would be interesting. I haven't, the last time I looked at the VES standard, it was, I don't think it mapped directly into the JSON format, but
it is JSON format.
It is JSON.
Yeah.
Okay, I'd have to look at it. Most of the logging we've been doing right now has been, the vast majority of our work has been to actually get it onto Kafka bus, not actually sanitize it so that it has a specific format. Okay. Alrighty, thank you all.
Thank you, Zach.